Hello and welcome back to another video. In this problem, we're told that the population of a certain species in a limited environment with initial population 100 and carrier capacity 1000 is P of t is equal to 100,000 over 100 plus 900 e to the negative t, where t is measured in years. So we're asked to graph this function and estimate how long it takes for the population to reach 900. So what does that actually mean? So if the population is 900, then that means that the y value, the p value of this function, is equal to 900. And so I have graphed this function. We have it in red right here. We can see that it starts very close to 0, it goes up to 1000 very quickly, and then it remains basically at 1000 forever. So what we have to do is we have to go to 900 and see, okay, the function reaches 900 at this point, which is roughly 4.396. So what does that mean? That means that at 4.396 years, we estimate the population to reach 900. So 4.396. We're next asked to find the inverse of this function and explain its meaning. So we have P of t is equal to 100,000 over 100 plus 900 e to the negative t. If we say P of t equals y, and then switch y and t, right, where this is y, we switch y and t to get the inverse, so this becomes t equals 100,000 plus 100 over 900 e to the negative t. Just to make this a little bit easier, I'm going to divide everything here by 100, right? You divide the top by 100 and the bottom by 100. All these zeros disappear, and we're left with 1,000 over 1 plus 9e to the negative t. We can, if this is t divided by 1, we can cross multiply. So this is 1 times 1,000 is 1,000 is equal to t times 1 is t plus 9 times t times e to the negative t. And, we have to swap t and p, so this becomes e to the negative p. Should have done that at the start. We want to solve for p, so we can subtract t. This gives us 1,000 minus t is equal to 9t e to the negative p. Dividing by 9t. These cancel, and we're left with e to the negative p, swapping this around, is equal to 1,000 minus t over 9t. And now we can take the natural log of this, right, to take out the exponent. So we'll get log base e of 1,000 minus t over 9t is equal to the exponent negative p. Therefore, p equals negative, log base e is ln of 1,000 minus t over 9t. So we're asked to explain this meaning. So this is, the original function is estimating the population at a certain time. So this is the time at which we reach a certain population. So it's sort of the opposite. And we're asked to graph this function to find the time required. So here, in the original function, we found the value of y being 900 at a certain x. Now, if we zoom out, we can see that our function down here, inverse function in blue, our x value of 900 occurs at a certain y, which we can see is roughly 4.394. That's the same value we got in the part A, 4.394. Obviously, they're not exactly the same because I didn't zoom in fully. So there's a little bit of error in my actual measuring, but both methods result in the same value.